They're placed inside the horseshoe-shaped steel frame, 2 inside the beam of the outer arc and 1 inside the beam of the inner arc. With these installed, the Skywalk frame is now structurally sound, but still no one knows how it will behave over the edge of the cliff. That test is still to come. Ten years after the idea was first proposed, the horseshoe-shaped frame of the Grand Canyon Skywalk is finished and ready for the next step. Now it's time to add the defining element: Skywalk's unique glass floor. Engineers choose a glass made up of 5 layers, a total of 8 centimeters thick. The layers are bonded together and laminated with a special interlayer adhesive to strengthen exposed edges and enhance clarity.
If they selected a glass and an interlayer product, it would give a very clear view.
Each pane measures about 1.2 meters wide and 3 meters long and weighs about 545 kilograms. While the steel frame of the Skywalk supports its own weight and that of the glass, each pane of glass supports a live load of 488 kilograms per square meter, or about 800 people. This far exceeds the 120 visitors allowed on the Skywalk at any given moment. To account for gravity and wind loads, the composite glass is measured to support downward forces of 488 kilograms per square meter. Additional strength tests project that the glass can sustain upward wind forces of 390 kilograms per square meter. Similarly, the thinner glass on the curved railings withstands 390 kilograms per square meter from any direction. Skywalk's glass walls were originally designed to be 2.1 meters high, but engineer Bill Caron fears that will feel too confining for visitors. So he proposes a height of 1.6 meters.
Now the code only requires it to be 42 inches tall, so we decided on 5'2", so we were a little bit safer than the code, but you don't feel confined when you walk the Skywalk. It's very open.
Visitors are required to wear cloth booties, but even so, small scratches and scuffing of the glass is inevitable. Fortunately, the 5-layer composite allows for periodic replacement of just the top layer, lowering maintenance costs to a fraction of full replacement. The machine used to move the large glass panes during the original installation and for replacement is called a manipulator. Powered suction cups on a crane-like arm pick up the glass. The glass is then tilted 90 degrees for one last cleaning. The operator then gently lowers the pieces into place. Although the glass is very strong, it is also very heavy and can break under its own weight if it falls or collides with rock or steel. The sheer weight of each pane presents a problem as the engineering team prepares to install the glass walkway. Because the box beams bend slightly under weight loads, the team worries that as each pane is placed, it will cause the steel to bend and possibly break a pane that's already been installed. Any miscalculation can result in a shattered piece of glass. To counterbalance the frame during installation, workers set out a layer of temporary steel plates to simulate the weight and size of the glass panes.
So we actually emulated the weight of the glass as if it was on there. So we went around and put steel plate on each section as if it was a piece of glass. So as we put a piece of glass on, we take a piece of plate off to make sure we had the right balance of weight. So it basically had that same bend, if you will, with all the glass on it at the end of the day.
And there's one final consideration in securing the sheets of glass. Spaced roughly 3 meters apart, the inner and outer box beams of the Skywalk move independently of each other. Over the course of a day, the heat of the sun and the weight of pedestrian traffic can cause the box beams to move, slightly shifting the glass panes up or down, creating an uneven surface. To solve this, small bearings are installed to compensate for these height variations and provide a level foundation and cushion for the glass. With the glass in place, it's now time for the big moment, to roll the giant frame out over the rim of the canyon.
We were very, very nervous, very anxious. It was very, very intense to make sure everybody was on the same page on what we wanted to accomplish.
The rollout crew has been preparing for this moment for months. First, they raised the frame off the temporary sawhorses used during welding. Next, they lower the frame onto the rolling jacks that will carry the payload to its ultimate location.
We use the old Egyptian rod plate method where you move one plate, you move the rod to the next position, you roll it a little bit and you move it again.
The Egyptians used this rod and plate method to move heavy objects like the blocks used to build the pyramids. At Skywalk, each section of the box beam frame is jacked onto a platform with a roll of rods underneath. The rollers minimize friction, so a relatively small force is needed to roll the structure in a straight line. 2 winch trucks are used to move the Skywalk. Pulling cables are attached to a temporary cross brace on the structure, fed through pulleys attached to the foundation columns, then run back to the trucks. As the winches reel in the cables, the Skywalk inches forward over the canyon's edge.
We were going to move 1,571,000 pounds over the edge of the Grand Canyon without having to go over the canyon.
It's not just the weight of the Skywalk they have to move. Because the engineers worry that the frame might tip over the edge, they pile 250,000 kilograms of steel plates on the back of the frame to counterbalance the weight. The team also worries about a runaway once the rolling begins.
Pretty hard to stop 1.5 million pounds once it gets going.
So they borrow another trick from ancient Egypt.
We basically would throw sand in front of the rod, and actually what that created was a friction between the rod and the plate, and it actually stopped the Skywalk.
2.5 years after the groundbreaking ceremony, the Skywalk team is ready. The rollout begins. Centimeter by centimeter, the crew carefully rolls the Skywalk toward its ultimate position, 21 meters away. They get halfway there after a full day.
We had to roll it out without breaking any of it. So move it out approximately 70 feet at 1.5 million pounds without breaking any pieces of glass, and that was a feat in and of itself.
On the second day of rollout, the methodical effort pays off. Skywalk reaches its final position. Now they have to secure it. The jacks gently lower the Skywalk on its foundation. As soon as the box beams are fitted over the 8 columns, welding urgently begins.
We then immediately started preheating the steel and running the beads, the weld beads. Well, each section, each side has 128 runs on top and on bottom, all the way around all 4 sides on all 8 columns.
The welders don't stop until the job is done. Then the entire crew breathes a huge sigh of relief. The Grand Canyon Skywalk is secure and ready to be unveiled. After 2.5 years of construction and $30 million, the horseshoe portion of the Grand Canyon Skywalk is complete in March of 2007. Over 500,000 kilograms of steel and glass extending 21 meters over the canyon rim, suspended over 1,200 meters of pure air. An engineering marvel showcasing a natural wonder. After extensive testing with X-rays and ultrasound ensures that the structure is firmly tied to its foundation, it's time for the opening ceremonies. It's the moment of truth for everyone who has risked making Skywalk a reality. They begin on a chilly morning with a blessing from the Wallapai spiritual leader.
All the tribal people came out. They were allowed to go on the Skywalk, and the man that had the idea to put the Skywalk here, David Jin and his family, and all the tribal members were here, and it was just very spectacular to have all those people together.
For the next 2 days, David Jin and the tribe welcomed the media and special guests, including astronauts Buzz Aldrin, the second man to walk on the moon, and John Harrington, the first Native American to fly in space.
This magnificent first walk bridges centuries of vision towards the future of hope.
The first step out on Skywalk, you really didn't know what you were going to experience. You couldn't see down the bottom right away. And then when you got on it, you looked down, and to see way down there sent chills and thrills down your spine.
You're actually walking on air when you walk out onto the glass floor and you look down and you basically see an endless sea of rock and beauty in the Grand Canyon.
When the gates open to the first customers, excitement mounts even more.
The one thing I would say was that if you were anywhere near this area, it would be a big mistake not to come here. It was definitely worthwhile. Definitely worthwhile.
And I thought I would be nervous or anxious or feel queasy. Not at all.
Visitors give their approval, but there is one cause for concern. A layer of cushioning foam between the glass and the steel beams provides an unexpected sensation on opening day.
When you first walked it, you could hear a little crunching sound. So it's kind of crunch, crunch. But as thousands of people have walked it, the crunching has gone away, thankfully.
Worry about crunching glass may be history, but the fear and butterflies of first-time visitors remains all too visible.
A lot of times, first-timers will do something like this. They'll tap the glass with their foot, gain a little confidence and step, carefully bring out their second foot. Then they'll test it out a little bit like this.
See, we're okay. Just one step at a time. See, that's how you do this.
Now, some people are frightened to walk right down the center, so they'll actually scoot over to the side, and you can see right above the bridge beam. You can't look down. You can put a death grip on the handrail and then kind of work your way down the skywalk.